Okay, it's broadcasting successful. Let's do a quick check. Frank, I'm going to make you host just to verify that it transfers
Okay.
over to you for the video, because I'm noticing it's kind of focusing on me right now. Oh, I see how I can do this. Okay. Just allow.
Okay. Want me to share, or is that?
Hold on. Okay, I got it. Okay, so Frank, what I'm going to do is I'm going to transfer the host to you, and you can put up the first slide, I guess.
Sure.
Five minutes to go.
How's that looking?
20 seconds.
Can you still hear me?
Yes, I can, and I
Okay.
can see you there.
Okay.
So it is working.
Yeah, we should get a T-shirt with Duke like that. If Oracle would allow it. Actually, Duke is now open source, right? The image.
That's true. We actually have a Fab Lab where I work, so I think I can print T-shirts up there.
There we go, our own business.
That's what I mean. Most worried is since we've switched to broadcasting on YouTube is making sure everyone finds gets to the link.
Are people joining?
So as a result of Zoom bombing, we now broadcast on YouTube. So it's just the presenters and me on the Zoom call. And then we're broadcasting over YouTube and then taking questions from there.
Mhm. I see 5 of them are watching. So when we should start?
Oh. It's gonna sound really strange, but I'm having trouble getting back to Zoom. There we go. Okay, one more minute, get started. Okay, I'd like to welcome everyone to the June Connecticut Java Users Group meeting. A couple of quick announcements before we get started. Our next month's meeting will be announced shortly. Looking for probably the middle of July to avoid the July 4th weekend. Please do consider subscribing to our YouTube channel. I'm trying to get us up to 50. This is something new that we've started with the online broadcast. Previously, we were using Zoom and sending out Zoom links directly. Except after getting Zoom bombed back on our April meeting, we're now broadcasting over YouTube. So with the presentation today, there's a 20-second delay in the video between when we're talking when it actually gets broadcast out. You can ask questions on YouTube, so we'll see those instantly, or you can post them to Twitter as well. Either or will get us get the questions over to us. The session is recorded, so you will be able to watch it afterwards. So with that, I'd like to welcome Frank from the New York Java Users Group, as well as Zoran, Dr. Zoran from the University of Belgrade to give the presentation today. So with that, I'll hand it over to Frank.
Thanks, Ryan. Good morning, good afternoon, good evening, wherever you are. And if you're watching this on a recording, hello to the people of the future. Thanks for joining. So our talk today is about JSR 381 visual recognition for Java, and it's about a Java-friendly machine learning API. So Zoran and I will go through a few topics. Here's where you can find us and our Twitter handles. So what I'll do is that for the first part of the presentation, we'll talk about, just take a step back and talk about machine learning, AI, and patterns, and find out why that's critically important for all developers to understand what that means, and what importance not just to developers, but importance to the world and to civilization. And then Zoran will dive into VisRec, what we call VisRec affectionately, JSR 381 visual recognition, into the architecture implementation and talk about the API, since I'm sure most of you want to see the API and how to use it to create your own machine learning applications. And Zoran has a really cool demo that he could show you, that he will show you, that it's an explanation of how to use the API. So why JSR 381? I'm glad you asked that question. So why JSR 381? So we know that machine learning and AI, it's a discontinuity. In other words, it's a new trend, a long-term trend, and it's critically important. This is important as electricity or the printing press, or even a picture on the left-hand side of the screen, or computers. And honestly, the term computer actually refers to the women programmers. They were called computers, which is kind of interesting. And now we have AI and machine learning. So these are watershed moments in our history, right, in civilization. And they're long-term trends, just like those other trends. So this is something that you really have to consider. We're not just talking about a simple framework to understand how to use a framework. This is a huge trend for our entire planet. And just to take a step back, we're talking about machine learning, but just to be formally correct. So the big topic is artificial intelligence, AI, right? And we know that, as the words say, it's a type of algorithm that mimics intelligent human behavior. Now, you can argue that human behavior is not always intelligent, but that's a topic for another time. So that's the big topic. Then we have machine learning as a subtopic, and we're all Java people here, so it's a subclass of AI. It's one type of subclass of AI. There are other types, the expert systems, rule-based systems. That's another type of AI. You can write your own program that uses your own algorithms to mimic human behavior. That's another type of AI. But we're specifically talking about machine learning, where it's a set of algorithms that allows a machine to learn from data, patterns in data. And you would guess, like, patterns in data is what we define as experience. If you tell a human being, that's what experience is. But specifically, there's a subclass of machine learning called deep learning. So deep learning, again, a subclass of machine learning, which is a subclass of AI. Deep learning is a type of machine learning that uses modern computing resources. So we have the cloud, we could spin up VMs, we have GPUs, we have TPUs, we have new types of algorithms, advanced neural networks. So we have more computing resources. So what we're talking about now is really formally deep learning. But in the press, you'll see that, people call it machine learning. Sometimes they'll call it AI, but specifically we're talking about deep learning. But we'll call it a machine learning, just among friends here. So basically, what is it? All right, and we'll talk about this before we get into the details of the JSR. So when we learn a foreign language, so there's two ways of learning a foreign language, right? We could spend a long time learning the rules, right, about nouns and pronouns and verbs and prepositions and the structure of a sentence and how to form a sentence to communicate with another person. And we could spend a long time with that. We could spend years figuring out the structure when we understand all the rules. Alternatively, we can have a friend tell us, we can start speaking, and when we make mistakes, our friend corrects us. So our internal model of the language changes as we make mistakes, or if we were correct and our friend says, yeah, that's exactly right, that's the way you should say it. So it's by observing patterns and following patterns that you learn a foreign language. So that's the second type of how to learn a foreign language. So what we've been doing in programming and for decades is the thing on the left, right? We've been defining programs with hard, rigid structures, right? We know all the Java frameworks, and we know exactly where to put this class and that jar file, and where to put it in the cloud. And so we know all the rules, and that's the way we've been doing things for decades. But now let's talk about the thing on the right, right? This is about observing patterns. So the word patterns. So we've seen the word patterns around, right? Certainly, if you've been around for a couple of years, you know this book very, very well, right? It's design patterns, right? Certain types of things that we've seen in languages, programming languages, are now codified in whether it's Java or C++ or other language. Now, this book was designed after a talk that Kent Beck and Ward Cunningham gave at an OOPSLA conference, or an object-oriented programming conference, called their talk was using pattern languages for OOP. And notice the word, using pattern languages for OOP. So that inspired this book. So this book was designed on a pattern. And this book, a pattern language from 10 years before that, was about building construction. It wasn't about programming, it was about building construction. This book inspired Ward Cunningham to come up with pattern languages for OO. And it directly led to his creation of Wiki. And it also influenced the development of Agile. This is building construction. So there are patterns in building construction. And it turns out that those patterns weren't just invented a few years ago, right? Like 40, 50 years ago. They go back centuries, right? And they're patterns, what worked, what didn't work. So we've learned what we're doing in software actually comes from these buildings that are based upon patterns. So that's interesting, the word pattern. If you kind of step up from your desk instead of looking at Java code, and you kind of take a look around and goes, wait a minute, patterns are all over, right? So if you're playing sports, right? If you're playing football and you know the patterns of your opponent, you know how to play the game if you know the patterns of your opponent. And likewise, your opponent knows your patterns, right? To play. Then if you're playing American football, where we don't even use our feet to play football, which is another topic, there's patterns that you use against your opponent. But wait a minute. Animals use patterns. The bear knows where to catch fish. So the bear knows how to detect patterns to get food. Well, wait a minute, there's fractals. There's fractal patterns. There's patterns in business with problem solving and how innovation comes about. There's patterns. There's patterns in astronomy. I mean, I studied astronomy in university. There's patterns in astronomy and also in music. Right, Zoran and I are both musicians, so we know that if I tell Zoran that we're going to do a 1-4-5 in the key of C, Zoran knows how to play that chord progression. And if I say we're going to do a 2-5-1, a jazz song, and a 2-5-1 in A, he knows what the chord changes are. So there's patterns not just in software, right? There's patterns not just in Java, not just in software. But there's patterns all over the place. Every place we look, there are patterns. And it turns out that this computer scientist, way back in the 40s, has this interesting quote. One of the most interesting aspects of the world is that it can be considered to be made up of patterns. So this was before the seminal AI conference, which is 1955 or 56 at Dartmouth, where that all the big brains of AI had their first AI conference. This is before that conference. So this computer scientist, this was AI before AI. And I would say to even refine this, it's not just the world, but the universe is made up of patterns. So this is really, really interesting. So the core of ML, right, the core of machine learning, this is something that for all you developers to appreciate, is that it's recognizing patterns, coming up with a model of the data. And once you have that model, is to make now predictions against that data or predictions against new data. So it's recognizing patterns and then making predictions. But if you're in business, right, and you want to convince your boss that we should do ML, like your boss comes to you one day and he or she says, well, what's ML and how can we use it? Well, this is how you get your raise, by saying something like this. You say, well, machine learning is about recognizing patterns in your data. And so we can anticipate future behavior since we know about patterns, right, of similar data. And then we take steps to maximize ethical business benefit based on those predictions. So there's like 3 steps. You recognize patterns, you can make predictions, and now you can prescribe next step for a business. So this is why businesses are interested in ML. And this is how you get your raise, by telling them this particular quote. So he said, well, how do we get started? Well, you can write your ML app in any language you want, as long as it's Python, right? So I'm stealing a quote from Ford, Henry Ford, when he had the Model T, right? And you have any color you want, as long as it's black, right? That was his famous quote. But we're Java developers, right? We're Java developers, okay? There's 10 million of us. So are you telling me that 10 million of us have to learn Python to do machine learning? So exactly, hey. So Java needs to be a first-class citizen for ML, right? So we have this brand new trend, this new trend in civilization called, AI, ML. We don't want one language for this entire phenomenon, right? And that's why the JavaScript doomsday scenario. There was only one language to express all of our creativity. So it's like if like in music, let's say okay, I'm going to give everybody a clarinet. Nothing against clarinet. Hopefully, I'm not offending any clarinet players out there. But to express yourself musically, you only have a clarinet. And that's it. That would be rough, wouldn't it? So we don't want one language to express the world's creativity, because there's different people. We have different brains, right? We have different ways of expressing creativity. So Python is a very good language, right? It's a good language for certain things, just like Java is a language for certain things, right? And JavaScript is for certain things. But there should be other languages to express the world's creativity, right? And we know we're all Java lovers, right? And there's 10 to 12 million of us. But the problem is that the existing APIs aren't Java friendly or app dev friendly. And Zoran will go into more detail into this. So back now it's 4 years ago, I was running a conference. We were a conference in Italy, and the keynote speaker, Humphrey Schill, he was a Java developer for like 20 years. And he was told he was going to be working on a machine learning application. He said he was forced to learn Python. And he said he had a hard time expressing himself with Python. Well, he learned it, and he said, I got to be pretty good with it. I couldn't express myself the same way for production purposes like I did with Java. So he has this really cool article, and I have the bit.ly link down the bottom right, or you can just go to Medium and search for Humphrey Schill. It's a really good article, and it was a dinner that we had, and we just, for several hours, we chatted about what Java needed for ML. So he sort of summarized that. So it's a really cool article. So the thing is that we need to promote Java for ML, right? We can't have just Python, even though Python's a really good language. We need to promote Java for ML, right? And we want to make it more approachable for Java developers. We don't want to create a C library with a simple Java wrapper, or C++ library with a Java wrapper. We want to create Java-friendly APIs, right? Things that we all know and love. So Zoran and I were giving talks at Java 1 and Code 1 for years on ML separately. And when, as both members of the Null Pointer house bands, we started talking about ML, and we realized that we both wanted this. We both wanted to promote Java for ML. So we said, well, this Alan Kay's famous quote, the best way to predict the future is to invent it. So let's just do it. So we talked to all these companies, all these big companies, on what they thought of Java and ML. And we were, honestly, we were fans of the topic, but we didn't realize how interested all these big companies were in having Java for used with machine learning, especially in production systems. I mean, we talked to Brian Getz, we talked to people at Google, on Twitter, IBM, Zool, everybody. So everybody was interested in this. So we said, like, instead of coming up with a boil the ocean approach, let's just do visual recognition as just like one application of machine learning. So Zoran and I got together with one of our colleagues, Kevin, from Open Value at that point, and we came up with a standard API for visual recognition. And we had a lot of help. Well, people from different companies, and some of these names are familiar to a lot of you. A lot of them are Java champions or Jug leaders or senior developers and architects. So a lot of people helped out. And Amazon actually was impressed with our JSR, so they implemented our JSR using their DJL library. There's an article on InfoQ on how they implemented our API. So here's a high level. I mean, you can read what JSR 381 is. Certainly that Zoran will go into detail, but essentially we want an API that was designed for Java app developers, right? Something that was Java friendly. Again, not a C++ or C library that's wrapped with Java syntax and it sort of doesn't feel like Java. We wanted a real bona fide Java API. So with that, let me turn it over to Zoran, who'll talk about the architecture and show you the API in a cool example.
Thank you, Frank. Can I just have screen sharing? I'm not able to share screen at the moment. I don't know why. Okay, thank you. So hello, everybody. So as Frank already mentioned, there is actually a number of Java machine learning libraries and AI libraries in general. But with that many libraries, there is one problem. Each library has a different API, just like in before Java time when everybody was writing their own collection libraries, right? Before there was a collection API. So there's different sets of algorithms for different problems. And when it comes to visual recognition, there are different imaging classes. Many libraries have different dependencies to native libraries. And sometimes it is very difficult and frustrating for Java developers to make everything work and integrate in their Java applications. And already, also as Frank mentioned, many of them feels like C library, C API, which is just written in Java. So not very intuitive for Java developers to put their hands on and get started doing what they want to do. More focusing on solving technical problems and learning low-level details. So having this situation in mind, we set the following design goals and principles. So first, we want to create the API that can be easy to use by non-experts in visual recognition or machine learning domain. So you don't have to know all the details about the pixels, pixel layout, or how different machine learning algorithms and configuration settings should be used. And most of all, we wanted to enable Java developers to be able to use machine learning using their already existing Java skills. On the other hand, we are aware that we don't want to reinvent the wheel, and it is not possible for us to re-implement all the algorithms and all the details that are already available out there. And so we wanted to make it easy to implement that API to be easy to implement by existing machine learning libraries and imaging libraries. So to kind of promote interoperabilities among this Java machine learning ecosystem. And our long-term goal is to reuse that design for other types of machine learning related problems. So not just only visual recognition, but any kind of data recognition problem, or sound recognition, or any other type of machine learning application to have with the reusable general design. So we believe that we have achieved that, and the way we did it is that we started from a very high level tasks. So what can you do with the machine learning? And basically, I would say that like 70% of real world machine learning applications come down to one of 2 or 3 tasks. The most widely used is classification task, which is just assigning some objects or data into different categories. So the algorithm should be able to learn and then to classify objects by different patterns into predefined set of categories. So input can be data, or input can be images, or input can be sound, or it can be natural text. But on lower level, somewhere down the entire process, you convert those inputs into vectors, into like some kind of numerical form that machine learning algorithms understand, and you say, okay, this is a rabbit, or this is a penguin, or any other kind of object. The other type of tasks is a so-called regression tasks, which is actually tasks of estimating the numeric value of something, which is very close to function approximation, like a statistical function approximation. And the output of that algorithm is actually some value. So you want to predict application performance, or you want to predict marketing budget, or you want to predict the number of banner clicks, or anything else that is can be expressed in numerical terms. So the interesting thing to mention is when it comes to object detection task, it is a combination of those 2 basic machine learning tasks, which are classification and regression. And here we are using regression algorithms to determine a position of object in the image, and the classification to determine which kind of object it is. So these are 3 types of tasks that we set as an initial scope of this machine learning API, because they are very basic ones, and most of the real world applications come down to some of these tasks. So on this image, you can see the architecture of this entire API, and the way that we are making it very easy for end users to use it. So end users here, I mean by developer who is using this API for their application or their library. And what he sees is this public API, which is task-oriented and very user-friendly, as you're going to see on the in the following slides. But under the hood, there is a service provider infrastructure which can load different implementations of the API, meaning it can use different machine learning engines. And that's how we want to enable different existing machine libraries to benefit from this API. So one of the common questions when Java developers wants to start with machine learning is which library should I use? Because this decision can impact, have a long-term impact whether he will be able to change something in future if he figures out some limitations and problems with his choice. And in general, how much he's going to invest time in learning some specific machine learning library, which is not can be time consuming for someone starting with machine learning. So this API in some way solves that problem, because developers needs to learn the standard API, and then he can, in future, if he figures out that something does not works from him, he can just switch the machine learning provider to use the different machine learning library. How this works? First, we have created like a generic machine learning layer, which provides abstractions related to those machine learning tasks that we have explained in previous slides, that is classification, regression, and object detection. And service provider interface is a well-known Java infrastructure which can load specific implementation of these interfaces in the application during runtime, and that's how the application does not needs to know the details or the how the specific features and machine learning algorithms are implemented, as long as they conform to the interfaces defined in this generic machine learning layer. Now, these tasks would require of the developer to know the details of machine learning algorithms, but in order to apply them for a specific problem, we have added another layer on top of it, which is like a visual recognition layer, which provides specialization of these generic machine learning tasks for visual recognition, or that can be image classification and object detection. One of the problems here is there are many Java imaging libraries and many different imaging implementation. So we add another part of it which provides image abstractions using a factory pattern, so a user can load different types of images. For example, if we are using standard Java, we can use buffered image, of course, or if we are on Android, we are using bitmaps, or on other platforms which may require different, some specific imaging for microscope imaging or space imaging. Just a different implementation of this image abstraction is required. And on the high level, the user has a very friendly task-oriented API, which is specialized for a specific application, which he can change, and he can change the underlying implementation at some times if it turns out that some choices in the past are not good enough. So here is the example how this looks like. Actually, it follows the design pattern, which is very common in entire Java API. So this is one segment related to classifiers. So we have generic interface classifier, which represents a classification task, and we have two generic parameters which define type of input and type of results. So type of input can be image, or can be some products, or can be users, or can be anything else, user-defined object. And the return type is the, let's say, it can be name of the classes as strings, or it can be enum, or it can be some user-defined class. Then, if we want to classify images specifically, we do have an image classifier. So this is further specialization of classification task. And in order to make it easier for other libraries to implement that interface, we are introducing abstract image classifier, which provides some boilerplate code for making easily integrating into the API. And the main part of it is part of the API is actually part of the reference implementation, or part of the implementation is image classifier network, which classifies buffered images using convolutional neural network. So this is the general pattern, and I think it is very easy to follow and to understand what's going on, easy to implement, and most of all, which is important, easy for end users to use it and understand what the code is doing. Now, one of the problems that we saw is that in order to promote interoperability between libraries is to provide a common data set for different libraries. Unfortunately, I think each machine learning library out there have their own data set. I mean, like having their own list, right? Or having their own collection. So we provided this data set interface, which contains objects of type T, generic like parameter. And for image classifier network, we use image data set, which is just a collection of images. And these images actually contain buffered images, like a set of pixels, which are considered as input, and corresponding a label, which is a string, which defines a class of object to its belong. So I think this piece of a class diagram explains the general idea, and all other tasks are designed in a very similar way. So once you understand this structure, it is very easy to navigate around the entire API. Now, let's go to an example and see how this looks in action. There is a very funny and popular example of how to create image classifier in a TV show Silicon Valley, when they are creating an app which recognizes food. And actually it is a binary classifier, which means it can recognize only two classes, saying a positive class, which is a hot dog, and negative class, everything else that is not a hot dog, it is not hot dog. So it is very funny. If you haven't seen it, I recommend it. And it is very funny and brief tutorial what the binary classifiers are and how they learn. So in order to run this example, the dependencies that are required is VisRec API, which is available on Waymo Central. And this one is a generic API, VisRec API 105. And the other one is the reference implementation of that API. So I will switch now to this, to the code, and show you this hot dog and not hot dog project. I already have images here. So this you can see directory images, which contains two folders. One is hot dog. So this one contains various images of hot dog. So as you can see it here, right? They're very, very different. Some of them, it is clear that it is a hot dog, but on many of them, it is not from all the sources and other things that are available in image. So you can get the idea why it is difficult for computer to recognize what is a hot dog and what is not a hot dog. So the other folder contains negative examples. So this is many other types of food. And basically what we want to do is build the configure algorithm, which is able to say for the given image whether it belongs to hot dog class of images or it is belonging to not hot dog class of images. The additional files here are this labels file, which contains labels, in this case just hot dog, and this index file, which can also be automatically generated, which is basically just a list of files in these directories, and with each image we have this class, whether it is a hot dog or it is not hot dog or it is a negative class. So once we have these two data set prepared this way, and by the way, this data set is publicly available. You have a download link in the slides. This is how you build a classifier. So as you can see, this is a typical builder pattern, and here we have image classifier interface. So we have image classifier of what? Classifier of buffered images. I think this is pretty clear what's going on. And we have this implementation of builder, which takes using Java service provider, loads the available machine learning engine provider, and specifies all these configuration parameters for building the model. Now, this one can be tricky for developer to guess, and we are doing our best to provide all the details about this configuration in the Javadoc API. And mostly when you want to build your own model, you can just copy paste this code. And I think it is pretty obvious for some of them how to set. For example, what is the class for input images? What is input class? Here we specify buffered image. This one should correspond to this type of object that we are classifying. Then image dimensions, image width, and image height. Then labels file that we have already seen. Then training file, list of images. Now, the one that can be very tricky is this neural network architecture. And this one is available here, again, in a pretty much readable JSON format. So you can reuse, to say this, for like a starting points. And I think this input, this dimension of the input should correspond to the dimension of images. And you can see the typical configuration of convolutional neural networks having convolutional layers and max pooling layers for image classification. So we are not going to go into the details here, but just we'll say that this is something that you can copy paste and adapt to your needs. The important parameters here are also, so when you're training actually, how the entire training looks like. Let me just show you. So you have seen this one. The training process is the training algorithm is feeding the neural network with all these images that we have prepared. And in each training iteration, which is also called epoch, it is trying to minimize the error, the misclassification rate, if you want. And you see at this point, it is starting with training error 0.7, and along with each epoch, the error is going lower and lower. Hopefully, at the end of the process, if all parameters and configuration is set right, the error will be very low and accuracy will be high. So just to show you how it looks like, to start, we are not going to wait to train the entire model. It can take a few minutes, but just to show you demo, the entire demo is available on a GitHub repo, so you can clone it and try it for yourself. And this other parameters is max error. So it is the error threshold which you want to reach. So we want 0.03, which means roughly 3% of error. So this is the same thing, 0.7. And it takes about 4 seconds to run one iteration of, well, I think there is like a 500 or 600 or 1,000 images actually in total for Hobor, Hodog, and negative. So you can see how the error is getting slowly lower. And this learning rate parameter determines how much of the error on output is going to be used to fix the internal configuration of the neural network in order to minimize the error. And you can see the accuracy is starting to grow slowly and the error is going down. We can leave it training. And at the end of the training, you can export the model. You can specify in which time of which file you want to export the model. In this case, this is hotdoc.dnet. And we have like a serialized trained network that you can use in your applications. And you can see training accuracy is slowly going up. We'll leave it training. Actually, maybe not, because I'm going to run another example. Okay. So once this completes, I would say in about 3 minutes or 5 minutes, the way you can use this network is this other file, which can use train network. As output of the previous example, we have created this serialized train network, and we deserialize or load that train network from file, and then we instantiate image classifier network, right? It is an image classifier we use it for buffered images, classifier of buffered images, and we inject that this serialized network in a constructor. And the whole thing to classify the image is the classify method of this image classifier. Classify, and we provide this image. We load image via image.io read method, standard way. And as a result, we get a map which contains names of the images and corresponding probability. So if we want to get a probability, whether it is a hot dog, we get, say, results.get hot dog, get me a probability for hot dog class of images. And that's how we interpret it. If that probability is higher than 0.5, we can say, yes, there is a high probability that this is a hot dog. And if it is lower, that most likely this is not hot dog. So you can see here we are providing this pizza image, okay? It's saying most likely this is not hot dog. So this is a pizza, okay? And here we have a hot dog. And we provide this hot dog. It will say there is a high probability that this is a hot dog. So this is a hot dog and this is a not hot dog. It's very simple, and you can just prepare your images and try the same thing to build very simple binary classifier. So actually, the actual recognition, what you need to put into your application is this one line, which is very, very clear and simple and readable. So what's going on under the hood? The model is using, as I mentioned, convolutional neural network, which is a kind of specialized model for recognizing images. We won't go into much details, but basically we have adaptive filtering, like in Photoshop, this image processing operations, which apply some small matrix using convolutional operation, which is basically using this small matrix to slide over entire image. And the thing is, these numbers in these matrices, in these so-called filters, are learned using the same algorithm that neural network is trained, and that is a backpropagation algorithm. So basically, we have this feature detection, which is kind of image preprocessing, and then on the other hand, on the other end, we have a classification part of the model. And the big advancement using convolutional neural networks is that both parts of the network are trained in a single pass. So are trained at the same time. Before that, people had to manually design these imaging filters, which was very time consuming and gave usually poor results. So the minimal configuration for building image classifier is something that you should be easy to start with, to know which kind of images you're going to use, what are the measures of the images, what are the categories, what do you want to recognize, and then to create this labels file and reuse this architecture of the neural network and specify the name to train the network. Optionally, you have to play with different parameters to tweak the training, but that's another, I would say, more advanced details that we'll cover in future presentations. So this API, I think we believe that it solves the main pains and the barriers and fulfills the preferences for machine learning in Java, which it makes a standard API to work with many different incompatible data formats using this data set, and can work with the different machine learning algorithms by using service provider architecture. Also, we tried to keep these configuration parameters to a minimum and provide reasonable defaults, so you don't know to understand all the details of how to configure algorithm. At some point it might be required, but you should be able to start with using this API without need to understand all those details. So the main idea is to provide a clear task-oriented interface that will hide the implementation details, so you don't know how the underlying implementation works. Just like if you want to use like a binary sort, you just call collections.sort method and you get the most optimal implementations of the sorting without worrying what's going down under the hood. And most important, we believe that it provides a simple and portable integration into existing Java applications and devices, and with a lot of flexibility, because different machine learning engines can be loaded and implemented by using service provider architecture. This reference implementation of visual recognition API is based on DeepNet's deep learning library, the community edition, which is a pure Java based deep learning library, and it is available on GitHub, and we have quite some contributions from the community, so you can take a look at it. And the easiest way to use this library is through this WizRec API. If you want to get started and play with WizRec, so this is the link. You get these ideas, what are the main locations, and what to do, what are the main algorithms, so to get kind of inspiration for your own projects. And here is a little list of links with all the details about the JSR, projects on the GitHub, API reference implementation and examples, and mailing list that you can join to provide your feedback and ask questions. So, Frank, will you take over now? I'll pass it to Frank now.
Sure, thanks, Zoran. If you have any questions, I guess, Ryan, we can take questions from the YouTube. It's a 20-second delay.
Yeah, so if you have any questions, please feel free to pop them either into YouTube or on Twitter to let us know. I'd like to thank Frank and Dr. Zoran for the presentation today. So what's next with this library? What are features that you're considering adding? Where does it go from here?
So at this point, we are looking to get some real-world applications and get feedback from the community. And we are hoping to see more different implementations. So we would really like to see other libraries trying to implement this and telling us what would they like, what they don't like, and how we can all work together and push to make stronger Java machine learning ecosystem in general. Also, we are working on providing compatibility with the major existing machine learning libraries like TensorFlow, and especially with Keras API, so we can reuse trained models and import trained models from TensorFlow into this API. So Frank, I don't know if you want to add something.
No, actually, that was very well put. I don't think I can add anymore. That's exactly what we're doing.
Yeah.
No more questions so far. It's a little hard with the delay. Think of any other standard type questions.
Come on, people, don't be shy. Shoot at us.
So in terms of the differences between Java and Python, I've always been kind of wondered, why did Python take off with machine learning? I mean, originally when I was going to school, I thought Lisp ruled the roost with AI previously. How did Python take it over? Does it look like it's holding it? You know, what's happening with it, in other words?
Well, I can say my opinion. I think Python has been used extensively by the researchers and people that built a foundation. There were several libraries that became standard, like for numeric computation, for NumPy, then for data analysis. pandas and the matplotlib for visualization, which are all important for processing data and visualizing data. And the most important, there was the scikit-learn library, which has been for development on like 13 years. Recently now it has released the version 5.0, and it's been very strongly supported by Google, and started as a Google Summer of Code project. And it got pretty good adoption in community. So basically, if you want to do machine learning, and the easiest and the quickest way to start is use scikit-learn. Okay. So there is no, also there are some clones of scikit-learn in Java ecosystem. They are not that feature rich, and they have not been under development for like 10 years and supported by a big company and a strong community behind it. Many of them have some users and have strong communities, but not that large as scikit-learn. And there is a really high interoperability between different libraries in Python ecosystem, and that's what we are trying to do with this JSR.
And I can throw in my thoughts there. So Python is a great prototyping language because it has, as Zoran pointed out, it has the libraries available to help with prototyping. Because historically, well, in my career working for investment banks, there were always the statistics, as we call them, the quants working nearby, some of my friends, and they use tools like S+, SR, and these tools have the foundations, the libraries to help people prototype, but we never put them in production because it was difficult putting those in production for, we know about production issues, about things you have to change and things have to be rigid, things, the normal deployment issues. So we had to recode them. And back then it was rewriting it in C and C++ so we can deploy it properly. Python's a great language for prototyping. People have deployed some Python applications, but we know that there's 27 years of Java experience that we learned in deploying production applications. And a lot of engineers, like those big companies that I pointed out, they want to apply the lessons that we learned about deployment in Java to ML. So ML, it's sort of like how JavaScript rode the wave of the web, right? It usually takes like two technologies to jump on each other, and then that takes off. Well, that's what's going on with Python and ML. And then Java just needs the infrastructure, right? And tools like JSR 381.
Now, since this is JSR, is there any chance does that mean that it's on the path to being part of Java? Because I usually think of JSRs as feeding what goes into the platform. Is there, is any plans for that?
I think no. No. It doesn't have to be. I mean, it can be implemented as a part, kind of a module. But the most important now is to go to have different implementation and have to have real world applications using the JSR. Maybe in the future, when it becomes more clear which type of underlying hardware. At this point, is probably NVIDIA GPUs, but there are other deep learning accelerators that are going to be supported, and how will that be supported in Java? It would make sense to add this on top of that support. Something like a JavaFX is using GPUs at the moment. Now the same principle can be used for machine learning support over GPUs, but it doesn't have necessarily to be part of the core Java.
And also, as I pointed out, about an hour ago, this is a huge trend. It has a long tail. Right? This is not just like learning a simple framework. No, machine learning has a very long tail, and we're just at the start, right? Even though its origins come from the 40s and 50s, we're at the start of real use of it because of the cloud and hardware and everything coming together. So this is something that all developers should understand how to use. I mean, it's just has a super long tail, and there's AI hardware. There's conferences on AI hardware. I mean, conferences, not just one paper, but conferences on AI hardware. And what that typically means is that there's AI hardware. That means after AI hardware, there's AI software, and that's yet to come. So we're talking about the next 20, 30 years, or it's machine learning. And this is something for all developers to dive into. Your coffee's ready, Ryan.
That wasn't me, actually. Okay, I don't see any other questions coming in. So if there's any questions after the presentation today, feel free to ping CT Java at Twitter. I encourage everyone to subscribe to the YouTube channel, because future meetings will be posted up here. We definitely could have used some AI doing some image recognition on our April meeting when we were Zoom bombed, because it could definitely picked up on the not a hot dog bit. So definitely could have used that back then. So with that, I'd like to thank Frank and Dr. Zorin, and we'll see everyone next month.
Thank you.
Thank you.
Thank you very much, Ryan. See you.
Thanks. Yeah.
Bye-bye.